Yesterday we learned how to solve by elimination without multiplication, and today we're going to learn how to solve by elimination with multiplication. Sometimes adding our columns as they appear won't eliminate a variable for us. So if you look at this problem down here, if I tried to add them right away, I would get 4 plus negative 2 is 2x. Negative y plus negative 2y is negative 3y, and 20 plus 10 is 30. And so if you look, I still have an x variable and a y variable, so it's not really helping me solve as is. So in order to fix that problem, we would need to multiply one of the equations by a number to create opposite numbers so that a variable is eliminated. So what I mean by that is if I were to take this bottom equation and multiply every single number by 2, I would get negative 4x minus 4y equals 20. And now, if you compare the x's, you can see that they're opposites, so they're going to cancel out. So I want to rewrite those. I'm going to write my first equation, which I didn't change, and I'm going to rewrite this new equation right underneath it so that I can use elimination. Just like before, I want to add the columns. So I'm going to add these x's, I'm going to add the y's, I'm going to add the constants on the end, and when I do that, I get 4x plus negative 4x, so the x's cancel out. Negative y plus negative 4y, so that's negative 5y, and 20 plus 20, which is 40. Dividing both sides by negative 5, I'm going to get y equals negative 8. Then I want to take that y and plug it into one of my original equations. It doesn't matter which one. I'm going to choose this one. So I plug in 4x minus, I plug in my negative 8 for y, and that equals 20. This negative 1 times negative 8 would make that a positive 8. I would subtract 8 from both sides, and I get 4x equals 12. And when I divide by 4, that would mean x is 3. So my ordered pair would be 3, negative 8. When I look at this second example, I have a couple options, but since these 5s already match up, I just want one of them to be negative. So if I take this top equation and I multiply everything by a negative 1, that would help me cancel these out. And so I'll rewrite it right below. So 5 times negative 1 is negative 5x. 1 times negative 1 would get me negative 1y. 30 times negative 1 would get me negative 30. And now if I go ahead and add all my columns, I have 5x plus negative 5x, and so those cancel out. I have 2 plus negative 1y, so I have 1y left. And I have 30 plus negative 30, which gets me 0. So y is going to be 0. To find x, I need to take y and plug it into one of the original equations. So I'm going to use this equation. And so I would have 5x plus 1 times 0, which is just going to be 0. So that's actually just going to disappear. And then I have my equals 30. I divide both sides by 5. I get x equals 6. So the solution to this set of system of equations is 6, 0. On this next one, if I start looking at what I can multiply to get to cancel out, it seems like the easiest option would be these y's. Technically there's a 1 here. So if I were to multiply each of these by 3, that would help me to cancel these out. So if I multiply this bottom equation by 3, I'm going to get 15x minus 3y equals 39. Over here, I'm just going to rewrite my first equation with my new equation under it. And now if I add the columns, I should get these 3's to cancel out. So 2x plus 15x is 17x. 3 plus negative 3 would be 0. And 12 plus 39 would be 51. When I divide both sides by 17, I get that x is 3. And then I need to take that 3 and plug it into one of the original equations. So I'm going to choose the top one. So I have 2 times 3 plus 3y equals 12. 2 times 3 is 6. Plus 3y equals 12. If I subtract 6 from both sides, I get 3y equals 6. And when I divide by 3, I get that y equals 2. So the solution to this equation is 3, 2. Take a second and try to figure out what you should multiply one of these equations by so that the x's would eliminate. Hopefully you figured out that since the 2x and 2x already match up, you should just multiply one of them by -1. So if I multiply the top equation by -1 and rewrite it right here, I would have -2x minus 3y equals -10. From there, I'm going to add the columns. My x's cancel out. I have 5 plus -3y equals 2y. And I have 14 plus -10, which is 4. Dividing both sides by 2, I get y equals 2. I'm going to choose one of my equations. I'm going to pick the top one, but if you chose the bottom, that's okay. And I'm going to plug that y back in. So I have 2x plus 3 times 2 equals 10. So 2x plus 6 equals 10. I subtract 6 from both sides. I get 2x equals 4. And when I divide by 2, I get that x equals 2. So the solution to this system of equations is 2, 2. Go ahead and attempt this last one on your own. Pause the video for a few minutes and go ahead and attempt. There's a couple different choices to solve this problem, but since this y is negative and this y is positive, I thought it would be easiest to get rid of the y's. So I realized that if I multiply this top equation by 2, I would have 2x minus 2y equals -8. And then when I add my columns, my 2's would cancel out. So 3x plus 2x is 5x. 2y plus -2y is going to be 0y. And 7 plus -8 is -1. Then I would divide both sides by 5. And I get x equals -1/5. Then I need to choose one of these equations. So I'm going to go ahead and use the top one to plug x back in. So I get -1/5 minus y equals -4. I would add 1/5 to both sides, and I get -y equals, and go ahead and feel free to use your calculator for this part. If you need to type it in the calculator, you're going to do -4 plus parenthesis 1 divided by 5. Once you calculate that, you should get -3.8. And if you want your calculator to turn it back into a fraction, you're going to hit the math button and enter 2 times if you're using a graphing calculator. And the answer it will give you is -3 4/5, or -19/5. The last step is to divide both sides by -1, and so you get y equals 19/5. So your ordered pair would be -1/5, 19/5.